In this section, you learn the foundational principles of machine learning, including the importance of data, algorithms, and model evaluation. You explored how models are trained, validated, and tested, and the significance of bias-variance trade-off in achieving optimal performance. Delving into deep learning theories, you gained insights into neural networks, backpropagation, and various architectures such as CNNs and RNNs, understanding their applications in complex pattern recognition and sequential data tasks. Natural language processing basics introduced you to the intricacies of human language processing by machines, covering essential techniques like tokenization, stemming, and lemmatization, alongside advanced models for sentiment analysis, translation, and summarization. Reinforcement learning concepts further expanded your knowledge by focusing on how agents learn optimal behaviors through interactions with environments, utilizing reward signals to maximize cumulative rewards. Key methods such as Q-learning and policy gradients were discussed, highlighting their real-world applications in areas like robotics and game playing. In the context of AI ethics and governance, you explored the critical importance of ethical considerations and regulatory frameworks in AI development and deployment. Issues such as fairness, transparency, and accountability were underscored, alongside the challenges of ensuring AI systems are aligned with societal values and human rights. Overall, this section provided you with a comprehensive understanding of core AI domains, equipping you with the skills to apply these principles and techniques effectively while remaining mindful of ethical implications. The knowledge acquired here is essential for navigating and contributing to the evolving field of artificial intelligence, ensuring that technological advancements are both innovative and responsible.